Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Zoika Ruzaimi Zamrud and I'm from ECE521A. Okay, so for today I will present to you about our LAB3, which is part 1. For the part 1, okay, so we go to the question given. Okay, so as we can see, the procedure part 1. Okay, so the part 1 is for output. Okay, so it say set the connection of LED in the breadboard as shown in figure 2. Okay, then write a program using STM microcontroller assembly language that will turn on LED D1, D2 and D3 and then turn off. Okay, and then turn off those LEDs. Okay, so to make this programming, we will follow step by step. Okay, so for the first step, okay, as you can see, this is the first step. The first step is we need to draw the circuit given and write the question that they want, which is we turn on LED D1, D2, D3 and turn off them. Okay, so for the first, we will write the RCC AHB1ENR, which is 0x40023830. Okay, as you can see, this is the constant. This is the constant for the RCC. Okay, so it will place in port B. Okay, why it is port B? Because in the diagram, it show we are using only port B. Okay, port B4, port B5, port B8 and port B9. Okay, so for the next, we will write GPIOB model. Okay, so for the output, and its value is 0x40020400. Okay, this is also the constant number for the GPIO model. Okay, so as we know, GPIO model for the output has two options, which is for BIC and ORR. Okay, so we will need to do for these two. Okay, so the output is, as you can see, the output is PB4, PB5, PB8, PB9. Okay, so in this model, we will declare which part that we want to use. Okay, so first we will need to make the box like this. Okay, I will draw it. Okay, we will do the box like this. Okay, and first we will fill the box with number. Okay, so as you can see, we will use PB4, PB5 and PB8. We will turn on. Okay, so because of this circuit is active low, so we will write the 11. We will write 11 at PB4, PB5 and PB8 only, and PB9. Okay, so sorry, we will this is because we will use this four part. Okay, so we will put 11. Okay, model 5 11, model 8 11, model 9 11. And the other part that we do not use, we will put the 00. Okay, so we will fill the box with 00, the where we did not use. Okay, so that's for BIC. And for ORR, we will use 01 to the port that we use. As you can see, 01, 01, 01, model 8, model 9. Okay, so this for port we will put 01, and the other port that we did not use, we will put 00. Okay, so for the value of the BIC, we will get 0x000f0f00. So this is the value that we will put in the coding that we will use the LED. Okay. And this is for the value of ORR, which is 0x00050500. Okay. So we go to the next. Okay. So as you can see, next step is GPIOB ODR. Okay. So in this case, we will find the LED that we want to blink or to on, as you can see. You can say. Okay, so for the value of GPIOB is 0x 04002 0414. Okay, so this is the constant value. It won't change. Okay, so we will turn on the PB4, PB5, PB8, and PB9 we did not use because the question one asked us to only on 3 LED only. Okay, so because of this circuit is active flow, so we will put the 0 as on and 1 is off. Okay, so we go to the box given. As you can see, in the port 4, port 5, port 8, we will put the 0. Okay, so we can see port 4, port 5, port 8. Okay, so these three will be 0, and the other box that we did not use will turn 1. Okay, so for the value to on the LED, it will be 0x0000 FECF. Okay, so this is the value to turn on the 3 LED except PB9, port P9. Okay, so after that, to turn off the LED, we will put the number 1 to those port that we used earlier. As you can see, port 4. Port 4 is 1, port 5, 1, port 8 also 1. Okay, so this is the value, sorry, this is the value which is 0x0000FFFF. So this is the value we will put in the coding to turn off those LED. Okay, so we will continue to for the its coding. Okay, so as you can see, this is my coding for the question 1, which is we will turn on the LED 1, 2, 3, and after that we will turn off. Okay, so as you can see, okay, so this is the earlier that we do, which is RCC, AHBI, E, and R. Okay, so the GPIOB model, GPIOB ODR. Okay, so these three is the constant value to the coding. Okay, so the first one is for the RCC, AHBI, E, and R. Okay, so we will declare the R4, and after that we will make because of we use port B, so we will put the 2 here. If there is port A, we will put 1 and other else. Okay, so next is GPIOB model. So as you can see, GPIOB model. So this part we will declare which port we will use. Okay, so this is for the BIC. The value for BIC we get before this, which is 0x000f0f00. Okay, so this is for the BIC, and this is for the ORR. Sorry, for ORR we get 0x00050500. Okay, next we will use the coding GPIOB and we will get its coding is its value 0x0000 FECF. Okay, so this is the part which is to turn on the LED in the port B, in the port B4, 5 and 8. Okay, so this is the part. Okay, and for this part will turn off those three LEDs, which is 0x0000FFFF. Okay, as you can see here is 500 millisecond. So when it will turn on for 500 millisecond, and for this part it will turn off. It will turn off for 500 millisecond. Okay, so we will go check if there is any error. Okay, so there is no error, so we can just debug and we can run. Okay, okay. So we will go to the next part to see the simulation. Okay.
Assalamualaikum warahmatullahi wabarakatuh, and my name is Adam Asfabi Ramlan, and I will be continuing on part 1 question 3 for this lab 3 ECE521 and LED. Okay, let us first see the question, and our question is modify the program so that the LED will turn on one by one starting from LED D1 until D4. Okay, as we can see here, this circuit right here is the output of the STM32F446RE. How do we know that it is the output? We can see there is an LED and a resistor, and this connection is active low. How do we know this is active low? Because it is connected to the source, which is, as we know, the source is 1. So here at the port is 0. So we know that this is an active low connection. And before we go to everything, we must have a condition on how we want to know how we want to turn on the LED one by one, starting from LED D1 until D4. Okay, first of all, we can see right here we are using the port B. Okay, we are using the port B right here. So all the LEDs are connected to port B, which is B4, B5, B8, and also B9. Okay, you must list all of the condition first. Okay, as you can see here, the condition right here is we need to turn on one by one from LED D1 until D4. So we have 4 conditions. So the first condition is LED 1 turn on, LED 2, 3, 4 off. The second condition is LED 2 turned on, LED 1, 3, 4 turned off. Oops. The third condition is LED 3 turn on, LED 1, 2, 4 off, and final condition is LED 4 turn on, LED 1, 2, 3 is off. Okay. For first of all, if you want to make this connection or this LED the question happen, we need to first set the RCC AHP1 ENR first. Okay, we can see right here. So for this condition, we know that we are using the port B, which is GPIOB. So we need to put 1 on GPIOB, and the rest we need to do the masking, which we need to put 0. So we can see 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and GPIOB, we need to put 1. So 1, 0. Then how we want to know the register for this is we need to divide all by 4 parts. 4, 4, 4, 4 like this. So we know that 0, 0, 0, 0 is 0, 0, 0, 0, 0, 0, 0, 0, and 0, 0, 1, 0 is 2. So we have right here the RCCHB1ENR is here 0, 0, 0, 0, 0, 0, 0, 2. So we can put this as like 2 like this inside the coding. So the second one is the GPIOB model. We know that this connection is the output, so in output we have two, BIC and ORR. For input we only have one, which is the BIC. So we need to have two GPIO model, which is the BIC and ORR, because this is an output. We have LED and resistor, and we are connected to the source 5 volt. Okay, for the BIC connection, we know that for BIC, at the connection at the port, we need to put 1 1 1 1. For ORR, we only need to put 0 1. At where do you ask? At the port of the connection right here, which is PB4, PB5, PB8, and also PB9. So we can see it here. We have PB4, 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 Model 4, Model 5, Model 8, and Model 9. Like I said just now, for BIC, we need to put 1 1. So, can I color this? Let me check first. Where can I edit? It's okay. It's alright. I already edited this. So, model 4 we put 1 1, model 5 we put 1 1, model 8 1 1, and model 9 lastly 1 1. So how do you want to know the register number? We need to divide by 4, which is 1 2 3 4 5 6 7 8. So 0 0 0 0, as we know, is 0. So 0 0 0. 1 1 1 1 is F. So 0 0 0 F, 0 F 0 0. So for the BIC we have 0x, 0 0 0 F, 0 F 0 0. For ORR we need to put 0 1 on the port 5 4 5 8 and 9. So we have 0 0 0 0, 0 0 0 0, 0 0 0 0, 0 1 0 1, 0 0 0, 0 1 0 1, 0 0 0 0. So we need to divide by 4 parts of 4, which is 0 0 0, 0 1 0 1, which is 101 is the binary number for 5. So we have 0 0 0 5, 0 5 0 0. So on the ORR we have 0 0 0 5 0 5 0 0. That is for the GPIOB model. Oh yes, one more thing is why we use GPIOB model, because the port inside the question we use is port B. So it is a GPIOB model. We cannot forget that. Okay, now is the GPIOB ODR. What is GPIOB ODR? It is the condition for the LED to turn on or turn off. So right here, right now, we have 4 conditions. We have 4 conditions for this lab, this question 3, because we want to start off by LED1, D1 turn on, D2 turn on, D3 turn on, D4 turn on. So we need to have 4 conditions, which is we need to have 4 GPIOB ODR. Okay, because this is an active flow connection, we need to put 0 on the port, on the odd LED port, so that it will turn on the LED. So we have condition 1. Condition 1 you can see is LED 1 turned on. So LED 1 turned on, which is LED 1 is connected to port B4. So you can see here B4 4 here 4. So 4 we need to put 0 to turn it on. On the top of this we need to just mask it and put 0 on top. For the rest of the port we need to put 1, because this is active low. If it is active high, we need to put 1 on port 4 and 0 for the rest. So we can see here 0 0 0 0 on top is all 0, and 1 1 1 1 1 1 1 1 1 1 1 0 1 1 1 1. So we need to divide by parts of 4, which is we need to 4 2 3 4 1 2 3 4. So we have 0 0 0 0 F F 1 1 1 0 is E and F. So we have the register is 0x 0 0 0 0 F F E F. That is the coding for the register for first condition, which is LED 1 turn on. And you can see here LED 5 LED 5 8 and 9, the port 5 8 and 9 we put 1 because we don't want the LED to turn on. For condition 2, we can see condition 2, second condition, LED turn on, LED 2 turned on. You can see here LED 2 is connected to port 5, PB5. So we repeat the same thing as the condition 1, which is we put 0 on port 5 and the rest we put 1. On top of this we just mask it with 0. So we have 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1 1 1 1 1 1 1 1 1 1 0 1 1 1 1 1. So we put 0 on port 5 because this is an active low. We want to make the LED 2 turn on because the LED 2 is connected to port B5, which is the ODR 5. So we divide it by parts of 4, which is we have 0 0 0 0 1 1 1 1 is F, 1 1 1 1 is F, 1 1 0 1 is D, and 1 1 1 1 is F. So we have 0 0 0 x 0 0 0 0 F F D F. So this is the second condition, second register for LED 2 to turn on. And we have the third condition, which is LED 3 turned on. LED turned on, LED 1 2 4 off. Obviously we need to put 1 on the rest of the port. So we have here condition 3, LED turned on. So we know that LED 3 is connected to port 8, PB8. See here, PB8. So as usual, we mask the top on top of this because nothing. This is just the that's how it used to be. And on port 8, which is ODR 8, we need to put on ODR 8 we need to put 0 because we want to turn on the LED 3 on port 8. So on port 8 we put 0, the rest we put 1, and it will be 0 0 0 0, and parts of 4 again. 1 1 1 1 is F, 1 1 1 0 is E, 1 1 1 1 is F, 1 1 1 1 is F. So we got 0 0 0 0 F F D F F F D F F. Let's see. So F F E, pardon me, FE. This will make a confusion if we don't put the line parts by 4, because it will make someone confused. So let us see if we can put some of the we can put lines here. So we could put one here, one. Can we make it wait, I will try to make it, put some let me see, can I put some coloring here? I guess we can make it a square. So this is one part. This is one part. Oops. Oops. Maybe I don't need to, but that is just an information and a reminder to all of us to just put a line like this, so we do not be confused or wrong when we do our final year project or our exercise. Okay, so we skip to that, which is we can see that 1111 is F, 1110 is E, 1111 is F, 1111 is F. So you can see here is 0000 FEFF. That is the register for the third condition with LED turned on. And the final condition, the fourth condition, is LED4 turned on, and we have 0 LED1, 2, 3 off, and we have the LED4 on port 9. So LED4 condition for LED4 on port 9, you can see here port 9. You can see here port 9. I might have to small this a little bit. Make it small a little bit, and alright. I can make it so you can see it clearly. Alright. So on port 9 we need to put 0 because we want to make it turn on, which is what this is an active flow, and like usual on top of the board here we just mask it with 0 because this is not the condition to turn it on, and we put 0 on port 9, and the rest of the port we need to put 1. So we have 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 1 1 1 1 1 1 0 1 1 1 1 1 1 1 1 1. We need to divide it by parts of 4 so we can easily see what it is, what is the ranges number is. Okay, we have 0 0 0 0. Okay, 1 1 1 1 is F, 1 1 0 1 is CD. EF is D. Yes, it's D. 1 1 1 1 is F. 1 1 1 1 is F. So we can see here 0 0 0 0 0 F D F F. Okay, this is the first condition. The final condition, the LED for turn on. Okay, now we can see we have all the information right here, so we can put it inside our coding, so we can make the this condition turn on 1 by 1 from LD1 to D4 possible. So before that, I will explain what is this. This is this equation right here, this register right here. We can find it inside the formula, which is this is fixed, which is the RCC. This is the register for the RCC, GPIOB model, and GPIOB ODR. And if we want to put it in our Kyle or inside our coding, we need to declare this first. So this is fixed. We can just find it inside the formula, or we can just search it inside the internet, or we can remember it. Either one. So up to you, up to us. So This is the coding for this LAB3 LAB1 LAB3 question 1 part 3. So this is the coding for the to make the LED turn on one by one from LED 1 D1 to D4. First of all, we can see here area proc code read only export main entry. This is the main thing. This is the normal thing for us to start our program inside Kyle. So you can see here RCC AHBYENR is the 0 X40028232830 for the GPIOB model 0x40020400 and GPIOB model ODR with 0x40020414. Where can we find this? We can find this at here. We can find this at here. You can see here GPIOB model 0x40020400 for RCC AHP1ENR. You can find it inside this table, or we can also remember it ourselves, up to us, because we use GPIOB model. This is GPIOB model. And GPIOB ODR here with 0x40020414. Here is it, IH1BANER 40023 can find it there. First of all, we have the main, which is the LDR with the RCC AHB1ENR. So you can see we need to load the memory R4 into R5, and we have ORR. And where do we get these two? We get these two at where we find this just now, which is on the GPIOB 00000000, and 110 we know that is the binary number for 2. You can see here 0x00000002, or we can put this into inside our coding. Here this is, and okay, to store the memory of R4 and R5. Now we have GPIOB model, which we find it just now, and we want to load the memory for R4 into R5. We need to declare first the GPIOB model here first. We load R7. We can put it in R9 or R8, up to you. For me, I put in R7 0x00F0F00. Where did we get this? Inside here for the BIC and ORR. See here, BIC, we have 0x000F0F00. Okay, for a reminder, we cannot just put BIC, we cannot just store this number into BIC straight away, because F0 F00 0x000 F0 F00 is a large number for a binary, so we must declare it first, and then we need to BIC the register inside R5. Same goes to the ORR. We need to declare first, then we need to ORR R7 into R5 and store the memory to R5. This is the condition for all of our condition. This is coding for the condition, which is GPIOB ODR, which is where we find it just now for this condition LED1, LED2, LED3, and LED4. For the first condition, when we want to turn on the LED1, we need to load register R4, the GPIOB ODR. Here we have the L1, so this is our what we call the process of the condition. We can put it anything, put it my name, or L2, L3, or 4, whatever we want to put. So we need to load this 0x000FFEF to R5. What is this? What is this register? This is what we find just now in the GPIOB ODR, which is the first condition right here. You can see here 0x000 FFEF. So we put FFEF here, we store the memory into R5, and this is the delay with 500 millisecond. And same goes to the second part, which is we have the load R for GPIO ODR. For this is the second condition, we can load register this one 0x000 FFDF into R5. FFDF here is the second condition where we find just now, right here. 0000 FF 1110 is D, 1111 is F. Sorry, 1101 is D, 1111 is F. And you can see here the second condition, 0000 FFDF. Yeah, FFDF. And we store memory R4 inside R5, and we have a 500 millisecond delay in R0. So this is the third condition. We have 0x0000 FEFF, load it into R5, and store the memory R4 into R5, and we have a 500 millisecond delay. And the last condition is same as just now, just we need to copy paste before, because we want the only LED for turn on. We have load 0x0000 FFDF. Sorry, this is mistype. Here is actually FFDF. Here you can see here 1 2 3 4 F, 1111 is F, 1101 is D, and 1111 is F, 111 is F. It's actually FDFF. This is actually FDFF. Need to change it first. This is actually FDFF. So put it here. F F D F. Actually FDFF. This is actually FDFF. Because why is FDFF? Because you can see here where in condition 4 we have port 9. So port 9, only port 9 we put 0 because this is active low. So here port 9 we have 1 0 0 0 0. We need to parts of 4 divided with parts of 4, which we have 1111 is F, 1101 is D, 1111 F, 1111 F. So right here is actually FDFF. We need to store the memory R4 and R5, and also we need to put delay so it will not be fast. It will clip the light. It's not fast. And this is the coding for delay where we already learned before, and that's all for me. And I will show you the recording of the blinking LED from D1 to D4 after this. Thank you very much.
Okay, Assalamualaikum. Let's proceed for the part 2 for input and output. Okay, for the first step, we are going to declare all the address that we want. In this case, there is a 6 step that we have to use. On the first step, for the RCC AHP1 ENR, the address is 40023830, and for the step 2 AHB1 ENR are using the same address as step 1. We can conclude that we can combine this step 1 and step 2, and then the address will be assigned as 3 here.
So in this case, I am using the separate method to see it clearly in this step. For the step 3, we are using GPIOA model, and the address is 40020000. And for the step 4, for the GPIOB model, we are using the address 40020400. And then for the step 5, we are using the GPIOA IDR input data register 40020010, and for the step 6, GPIOB output data register 40020414. And let's proceed for the step 1. In this case, we are using the RCC AHB1E and R. The only port that we want is port A and port B. So therefore, on the first step, GPIOA will be 1 and the remain will be 0. Therefore, the RCC HP1 ENR will be 1. And then for the step 2, we only want the port B on. Therefore, the port B will be 1, the remain will be 0. And then the RCC HP1 ENR will be 2. This step we can combine because we just can put GPIOA and GPIOB turn on. Just put it 1 1 and the remainder will be 0. Therefore, the RCC AHB1 ANR will be 3. And then for next step, for the step 2, which is step 3, which is GPIOA model, to be informed that GPIOA model is only have BIC because it is input. So therefore, this is the table for the BIC. This is the BIC table. The port itself we are using is PA1 and PA4. Therefore, for the BIC table for this question, we have to put it input as 1 1. So therefore, for the model 1 and model 4, we have been assigned as 1 1. Then the remain the model will be 0. So therefore, the BIC value is 000000030C. And then for the GPIO B model, it is assigned as output. It is output. So therefore, we are using the PB4, PB5, PB8, and PB9. Therefore, for the output, we have BIC table and ORR table. For the BIC table, it will be assigned as 1 1, and ORR table will be assigned 0 1. In this case, the port that we are using is PB4, PB5, PB8, and PB9. So therefore, the model 4, model 5, model 8, and model 9 will be assigned as 1 1, then the remaining will be 0. So the BIC value is 000F, 0F, 00. And then for the ORR, we will assign 0 1. So for model 4, model 5, model 8, and model 9 will be assigned 0 1, then the remaining will be 0. So the ORR value is 00050500. And then for the step 5, GPIOA IDR input data register. So in this case, we are using the masking first. So in this case, for the question, we want to masking the PA1 and PA4. The reason why we are using the masking because we don't want the other port will be turned on. So in this case, we want only port A1 and port A4 only can be turned on. So for the masking, we have to put it 1, and then the remain will be 0. And then for the condition 1, where we want to enable the switch 1 and switch 2. So for this table, when we want to switch on the switch, when we want to press the switch 1, therefore we have to put the PA1 So therefore, in this case, IDR1 is 1, then the remain will be 0. And if we want to switch, to press the switch to, we have to assign one value to IDR4 because switch 2 is connected to PA4. So the remain will be 0. So in this case, when we press the switch 2, the address will be 0x00000010, and then when we press switch 1, the address will be 00000002. And then for the next step, for GPIOB ODR, output data register, there is a lot of condition here, because we want a lot of data to be used in order to turn on the LED. In this case, for the condition number 1, where we want to turn on the D1, LED1, LED2, and LED3, which is D1, D2, D3 will be turned on. And then we have to know it is active low or active high. In this case, it is active high. Active high because the switch itself is come from here. This will be input and this will be output. The switch itself is actually far from the power source. Therefore, the input that when the switch 1 and switch 2 when it press will be 0 here. And then same goes for the output. It is also active low because the power source come from here and enter to the STM32F446RE board. And then for the GPIO ODR, when we want to turn on the D1 and D2, D3 on, we have to set it active low. Active low is actually assigned to 0 value. So for the D1, D2, D3, it is assigned to the port PB4, PB5, PB8. So this port we have to declare as 0 to be turned on. So condition 1, ODR8, ODR5 and ODR4 will be assigned 0 value and the remain will be 1. So the address will be 000FECF. And then for the condition number 2, we want to D1, D2, D3 will be turned off. Turn off, which means for the active low, we have to set it, we have to assign a 1 value. So therefore the LED will be turned off. So the address will be 0000FFFF. And then for the condition number 3, we actually want we only want D1 will be turned on. So therefore on D1 it is assigned to PB4. Therefore the ODR4 will be 0. The remain will be 1. So 0x000FFEF for the D1 to be turned on. And then for the next step, for the condition number 4, we want D2 on. So for the D2 on, we have to assign for the ODR5 that actually on the question, the D2 itself is assigned on PB5. So ODR5 will be 0 value and remain will be 1 because it is active low. So the address is 0000FFDF. Same concept for the condition number 5 and condition number 6 where we want to turn on the D3 and D4. So therefore for the D3 is assigned to PB8. So in this case ODR8 will be 0. And if you want to turn on the D4 is assigned to PB9, so the ODR9 will be 0. So for the address on the condition 5 and 6, when D3 and D4 on, so for D3 000000FEFF, and for the condition D4 on 0000FD FF. So for the default condition, all LED turn off, is actually assigned to all the table. In this table, all will be assigned 1 as this table as in figure. So all the value is have been assigned to 1. So the D1, D2, D3 and D4 will be turned off. And then let's proceed to the coding. This is the assembly language for the part 2 question. So in this case, we are declaring all the address that we have listed on the diagram that have been shown here. So RCC, AHB1, GPIO-A model, GPIO-A IDR, GPIO-B ODR. So the address must be declared first on the top of it. So proceed to the main part. The RCC AHB1 E and R will be loaded into R4, register R4, and then the R5, the register, the memory location from the R4 will be loaded into R5, and then we can set the ORR using the counter of 2, the data of 2, because we got the value from here is 2, and for the RCC AHB1 ENR is 2, and RCC AHB1 and ENR is 1. So actually, if we want to simplify the coding, we can just use we can combine this instruction, which ORR will be 3. In this case, I am using separate ways, so I am using 2 and 1. And then for the GPIO-A model, will be loaded into a register R4, and the memory location on R4 will be loaded into register R5. And then for GPIO model, we know that on this question, GPIO-A is an input. Input is actually only have a BIC. So therefore, there is no ORR here, but we have to know that BIC only take 16 place, 16 bit. So we have to use the address that we got from the table GPIO-A model here. GPIO-A model for the BIC table 00030030C to be load into register 7 first, and then we just use the BIC from R7 to R5, then store the memory location and store the R5 into the memory location R4. And then for the next step, GPIO-B model for the output here, PB4, PB5, PB8 and PB9, it also have the same step as GPIO-B, but it just contain BIC and ORR. So the address for the GPIO-B model 00F0F00F0F00 will be loaded into register 7, then we will BIC it, and then for the next ORR 00F0F00 will be loaded into register 8, and we just ORR it to register R5. Then we store the R5 into memory location R4, and then proceed to condition 1 where the switch is pressed. So GPIO-A IDR input data register. So for the first condition, we are using the masking because we only want the port itself to be turn on when it will use. We don't want to be turned on when it is not used. So in this case, we are using the masking. The masking will be loaded into register R1, and then we'll end it on R0. Therefore, for the register that so when the switch, this is the switch one. So when the switch one will be turned on, and then we end it with the R0. So only the bit itself here will be turned on because n is actually multiply. So when the address will be multiplied, then the bit here will be turned on. So in this case, it will proceed when the switch will be turned on, it will proceed to condition 1. So when the condition 1 for the move R8 and hashtag 5, this is where I am declaring the counter. So when switch 1 is pressed, so the LED will blink 5 times. And then for GPIOB ODR, ODR is output data register, which is the LED, is assigned to load to register R4, and then the address that we want for the switch 1 will be turned on is LED1, LED2, and LED3 will be turned on. So in this case, the 000 FE will be loaded into register R5, and then we store the value into the memory location R4, and then we set the this is the time, or the we set for the millisecond to be LED will be turned on. So, and then for the condition, LED is turned off. So this is the value. So this is the when the LED D1, D2, D3 is turned on, and this is when the LED D1, D2, D3 turn off. So I am using the SUBB and compare because I want to use it blink for 5 times when the switch 1 is pressed. And then it will go to the L1, loop L1. So it will back in this condition. So we already proceed on the condition 1, which is the switch is pressed. And then for the condition number 2, when the switch 2 is pressed. So we are using GPIO IDR, and then we are masking into the switch 2. So switch 2 is assigned to PB4. So in this case, where we compare it for the R2 and R0. So when the switch is pressed, it will go to condition 2. So same concept on the condition 1, where I am using the counter for 5 times. So for the GPIO ODR, I am loaded to R4, register R4, and then for the condition where the LED D1 is turned on, therefore the address is 000 FFEF, and then using the instruction str for the address to be stored into memory location R4, and then it will be delayed for 500 milliseconds. And then for the second condition, where we want to turn on the LED2, therefore the address is 0000 FFDF, and then it will be stored into memory location R4, and it will be delayed for 500 milliseconds. Next, for the we want D3 to be turned on. So the address is 000 FEFF, and it will be stored into memory location R4. It also will be delayed for 500 milliseconds. And then for the next is we want to turn on the LED4. So the address will be 000 FDFF, and will be stored to memory location R4, and it will be delayed for 500 milliseconds. And then we are using a subtract and compare because we want to loop this for 5 times. So after the loop is done, then it will go to condition 1. So when there is no to loop 1, when there is no switch and switch, when there is no switch is pressed, then it will go to default location, where in here I am declaring when there is no switch is pressed, it will go to thing. So on the loop thing, the switch, the LED will be turned off. Here I am declaring when the LED all be turned off is 0000 FFFF, and will be stored to memory location R4, and will be and the delay will be 500 milliseconds. So to see the result, so this is this is our so this is condition where the LED D1, D2, and D3 will be turned on when the switch 1 is pressed, and as you can see, it will be blink for 5 times. Okay, when the switch is not being pressed, the LED will turn off, which is default condition. And then when the switch 2 is pressed, the LED D1, D2, D3, and D4 will be turned on one by one, and it will be blink for 5 times for the loop. And then when the switch is not pressed, the LED will back to default condition. And then that's all from me. Thank you.